Hello, this is Mrs. Snook with Section 2.1, Quadratic Functions. And our objective is to analyze graphs of quadratic functions and to write quadratic functions in standard form. Now, what your book calls standard form, you'll more commonly see written as vertex form. So y equals a x minus h plus k. That's what standard form is for your book. Our first example, we have two quadratic graphs to do. Our parent function is f of x equals x squared. This is your parent function. And it's really helpful to remember this as an xy table for the parent function. So -2, -1, 0, 1, 2, 4, 1, 0, 1, 4. So let's go ahead and plot this. -2, 4, 4, -1, 1, 0, 1, 1, 2, 4. So here's what our parent function looks like. That's not what I meant to do. Alright, I was going to see if I could just copy this. Alright, so I've gone ahead and I've graphed the parent function on both of these grids. Now, example A asks us to describe how the graph of g of x, which is -x squared plus 1, is related to the graph of x squared. And so we're going to use a, h, and k to decide how it's related. And remember, sort of our generic is going to be y equals a x minus h squared plus k. So if I look here at -x squared plus 1, I see a equals -1, and that causes it to flip. And then I see k equals 1, which causes the graph to go up 1. So let's graph g of x so that we can see what that looks like. So first thing we're going to do is a flip, which means my points are just going to flip over via x-axis. So there's my flip. I also need to move each point up by 1. So this point goes up 1. This point is going to go up 1. That point's going to go up 1. That one goes up 1. And this one goes up 1. So now I'm ready to graph g of x. So this one is g of x, the one that I did in red. All right, on our other grid, we're going to graph h of x. And that one is x plus 2 squared minus 3. So a here equals 1. So that makes no change. H equals, it's a 2 inside the equation. Remember, change your sign, so you get -2. So that's going to cause it to go left 2. And then k is a -3, so that's going to cause it to go down 3. So for the description, all I'm looking for is left 2, down 3. The rest of what I wrote is just to show the thought process. All right, so now let's take the points of our parent function, and we're going to shift each one of them left by 2 and down 3. So left 2, 1, 2, down 3, 1, 2, 3. That's this point. Now this point, go left 2, down 3. 1, 2, 3. Go left 2, down 3. Go left 2, down 3. Left 2, down 3. So here's h of x. Right through there. All right, next thing we're going to do is we're going to identify the vertex of a quadratic function. And they've written the function in the form of 2x squared plus 8x plus 7. Now, normally we would call that standard form, but your book doesn't do that. So what we need to do to find the vertex is we need to find h and k. Because that's where my vertex is going to be. It's going to be at the coordinates h, k. And my strategy for this is to complete the square. I do want to see you use this method on tests and quizzes. I know that in Algebra 2 you would do negative b over 2a, and then you would plug in and get the y. But this is a different strategy, and I do want you to learn this strategy. So we're going to start with our 2x squared plus 8x plus 7. And the first thing I'm going to do is I'm going to pull the 2 out of just the front. So that becomes 2x squared plus 4x plus 7. And to complete the square, I want to make sure that this piece here is a perfect square. So now I need to figure out what do I add into my shaded area to make that a perfect square. And we're going to start with identifying a, b, and c. So a is your coefficient in front of x. B is the coefficient in front of x. And then c equals 7. But now, since I've already pulled that 2 out, what I really want to use is, since 2 is pulled out, I'm going to say a equals 1 and b equals 4. And I'm going to use a and b to find what I call the magic number. And that's going to be b over 2a. So 4 over 2 equals 2. I'm then going to square the magic number. So I need to square this, square this, square this. That gives me 4. That's what I'm going to add. So I'm going to have 2 times x squared plus 4x. Add 4. Now, because I've added 4 in, to keep from changing my original answer, I need to also subtract 4 plus 7. So make sure you add and subtract your magic number. Okay? Now what I want is I just want a perfect square inside my parentheses. So I'm going to do a little bit of algebra manipulation. I'm going to say this is 2x squared plus 4x plus 4. I'm going to distribute the 2 just to this minus 4 to pull it out, so I get a negative 8 plus 7. Now, inside my parentheses, I now have a perfect square. And I can factor it to look like this, x plus 2 squared. Outside of my parentheses, I have the negative 8 plus 7. That gives me a negative 1. And look at that. We have a, h, and k. Which means h equals, well, in here, it's a positive 2. Change the sign, make that negative. And then k is going to be negative 1. So our vertex is at the coordinates -2, -1. The next thing we're going to do is we're going to identify the x-intercepts of a quadratic function. X-intercepts, that means where the graph crosses the x-axis. And it crosses the x-axis where y equals 0. So, I'm going to start with my -x squared plus 6x minus 8. And I'm going to set that equal to 0. So step 1, set equal to 0, because that's where it's going to cross the x-axis. So now I just have this. I don't like that negative in front of my x squared. So let's divide both sides by -1, and I'm going to get x squared plus minus 6x. Because when I divide, I change signs. Because all I did is divide by -1. Now I'm going to factor this. I'm looking for factors of 8. They're going to have the same sign because that's a +8. That sign is going to be a negative because I have a -6. So I have an x minus and an x minus. So factors of 8, that will add to -6, and that's 2 and 4. Now set each of these little equations equal to 0. So x minus 2 equals 0. Or x minus 4 equals 0. And the reason I'm doing this is the zero product property. And what that says is if one of my factors equals 0, then when I multiply them together, my answer will be 0, because 0 times anything equals 0. And then just solve each of these little equations. Add 2 to both sides, x equals 2. Add 4 to both sides, x equals 4. So now my x-intercepts are 2 and 4. And it says to describe the graph. So describing this graph, I have a negative in front, so I do have a flip. And I'm also going to, so it's going to be a parabola that's upside down. And it's going to have its intercepts at 2 and 4. So if I was to just sketch this graph a little bit, x equals 2, 4. It's flipped upside down and it crosses at 2 and 4. So it looks something like this. This is just a sketch. All right, next thing we're going to do is we're going to write the equation of a parabola in standard form. Now in your book, standard form is what we more commonly call vertex form. So y equals a x minus h squared plus k. That's what they mean when they say standard form. I am told the vertex is at 1, 2. So I've got h and k already. All I got to do is figure out a. So h equals 1, k equals 2. That's from the vertex. So my equation now is going to be y equals a x minus 1 squared plus k, which is 2. This is where it's nice to have the point. I'm told it passes through the point 3, -6. So plug in that point, and then all I have to solve for is a. So let's write down our steps here. Number 1, use vertex to get h and k. And then number 2, you're going to plug in your point. Plug in point. So let's plug in our point. x is -6, so -6 equals a times 3 minus 1 squared. And then plus 2 plus k. Alright, so now I have a -6 equals a times 2 squared. So -6 equals 4a plus 2. Now just subtract 2 from both sides. -8 equals 4a. Then a is going to equal -2. So here's our equation. So step 3 is we're going to solve for a, and our equation is y equals, plug -2 in for a, x minus h squared plus k. So just plug in the a, h, and k that we get. And that's your answer. All right, the next thing we're going to do, and this is a real-life situation, is the baseball. So if you can imagine at the baseball field, they pitch the ball, and then the batter just hits the ball, and it's going to travel in this parabola shape. So we can use a quadratic equation to model that pathway. And right here we have an equation. It says that the ball is hit at a point of 3 feet above the ground at a velocity of 100 feet per second. So once the batter hits that ball, it's going 100 feet per second at an angle of 45 degrees with respect to the ground. The path of the baseball is given by the function, so use this function. It's given you the equation. It says where f of x is height of the baseball in feet, and x is the horizontal distance from home plate in feet. What is the maximum height reached by the baseball? Maximum. We're going to use that equation and our calculators to find the maximum height. I can pause my. All right, so I've pulled up my calculator, and what I'm going to do is I'm going to graph this. So let's put this where I can see. All right, so I need to do -0.0032x squared. So -0.0032x squared plus x plus 3. Oh, and I have to turn off. So if you're stuck here where you've got these points here plotted, go to second stat plot, and we're going to turn this off. And then I also need to adjust my window. So I'm going to do a zoom. I start with this zoom standard. All right, so here's my graph. I had to zoom out quite a bit to see the parabola. And what I want to find is the maximum. So just like we did back in chapter 1, use your calculator to get the maximum. So I'm going to go, I lost my calculator. I'm going to go second, and then I'm going to go to, I'm going to hit that graph button. I need to just move this out of the way. All right, second, let's get into the graph. Second, trace, that opens up the calc window. I want the maximum, which is going to be at the vertex. And it's going to ask me to set left bound, so it's like which window should I look for a maximum. So where I have it right now is fine. I'm doing the right bound. Just make sure you go past your maximum. So anywhere over here is fine. All right, so read it off your calculator. And my maximum is at x is 156.2 and y is 81.1. So my maximum is 100, I'm sorry, I can't remember the numbers, 156.2 and 81.1. So that's the location of the maximum. That means that the maximum height of the baseball is the y coordinate. So max height is going to equal 81.1 feet. All right, that's it for today. Thank you for watching and have a great day.